In this video, we're going to look at using the scalar product formula to solve these types of questions. So let's have a look at this. The diagram shows two vectors A and B with the magnitude of A, i.e. the length of A, being 3, so this is 3 units, and the magnitude of B, i.e. the length of B, being 2 root 2 units. What a lovely number. These vectors are inclined at an angle of 45 degrees to each other. Fair enough. Evaluate, blah, blah, and blah, and we'll carry on with B in a second. So let's do part A, part 1. So A dot A. Now, on this side, let me just go over the actual scalar product formula. So that states that cos theta, the cos of the angle between two vectors, is A dot B over the magnitude of A times the magnitude of B, where A and B are my two vectors. Now, if I was to rewrite this for A dot B, so I keep my A dot B where it is, and these two, which are currently a divide, if I move them over to the other side, they will become multiplied. So it'll be the magnitude of A times the magnitude of B cos theta. Hope that makes sense. Now, this is what I'm going to be using throughout this question. This is key. So it's really this formula, just rewritten. Now, what I have is not A dot B, but A dot A. So we can rewrite that using the formula, like expand it out effectively, as the magnitude of A times the magnitude of A cos of the angle between A and A. Bit unusual, but doable. The magnitude of A, well, we've already been told is 3. Times the magnitude of A, which is 3, times cos of the angle between A and A. Now, the angle between A and A is just 0 because, well, there is no angle between the vector A and itself. So simple as that. You could just ignore this altogether and just have magnitude of A times magnitude of A. However, for the purposes of this video, I want to keep it complete in case people start wondering. So to avoid questions, I'm putting it in. So 3 times 3 is obviously 9. Cos of 0 is 1. So 9 times 1 is just 9. That's that first bit done. Now we're going to find the magnitude. We're going to find B dot B. Exact same principle applies here. So B dot B will be, no pun intended, the magnitude of B times the magnitude of B cos of the angle between B and B. So that will be, the magnitude of B is 2 root 2 times 2 root 2 cos, and again the angle between the vector B and itself is 0. There is no angle between B and B. So, multiplying this out, so 2 times 2 is 4, root 2 times root 2 is 2, 4 times 2 is 8, times cos of 0 is 1, so that's just 8. Easy as that. These will be a mark each at most. Now we're going to find A dot B. Exact same principle, yet again, nothing changes. So part 3, so A dot B will be the magnitude of A times the magnitude of B cos of the angle between them. Okay, so the magnitude of A, we already know is 3. The magnitude of B is 2 root 2. And the angle between A and B, if we go up and have a look, just to remind ourselves, it's 45 degrees. So it's cos of 45. Okay, so that's going to be 6 root 2 times, and you should know your exact values table, cos of 45 is 1 over root 2. Good news, these cancel out. 6 times 1 is just 6. Nice and easy. Okay, so that was part A. Part B. Another vector P is defined by P equals 2A plus 3B. Evaluate P dot P. Guess what formula we'll be using? Yep, this again. And hence write down the magnitude of P. Okay, so we have been told that P is, let me just remind myself, 2A plus 3B. So 2A plus 3B. Okay, so that means P dot P will be 2A plus 3B times 2a plus 3b. So we just used FOIL to multiply this out. So that will be 4. Now, a lot of people would go, oh, that times that will be 4a squared. Yes, but it's better in this situation to write it as 4 a dot a, because then we know what a dot a is. It's 9, so we can replace that with 9. And we're going to just do that. So it would be 2a times 3b is 6ab. This gives me another 6ab. Well, this gives me 6ba, but that's the same thing as 6ab. So in total, I have 12ab. And multiplying these two together gives me 9. And again, we write it as b dot b. You can write it as b squared. It's the same thing, but better if you write it as b dot b. So now subbing everything in, for a dot a, just to remind ourselves, a dot a is 9, b dot b is 8. So it'll be 4 times 9 plus 12 times, oh, what was a dot b actually? A dot b was 6. And b dot b was 8. So that's going to be 36 plus, oh, here's my times table, 72 plus 72. So that gives us a grand total of, let's work this out, 180. And that's us. Simple as that. Just to finish this off, we also want to find out the magnitude of p. Well, the magnitude of p is the same thing as p dot p rooted. Now, a lot of people will ask, pardon, what? Well, if you think about it, p dot p is the magnitude of p times the magnitude of p cos theta, yes? But the angle is 0 between p and p. So you can literally, like I said before, ignore this, so it's just p dot p. Magnitude of p times magnitude of p. So if you just want one of these two, and again that can be rewritten as that, running out of space here, so that can be rewritten as that. So if I just want the magnitude of p, then I can write that, take my squared over to the other side, and it just becomes a square root of p dot p. So a little bit unusual, but I guess it's a test for the slightly more gifted students, or anybody who's watched this video. So, using that principle, let me just, I haven't left myself enough space, so I'll just do it over here. So the magnitude of p is going to be root p dot p, and p dot p was 180, so it's just root 180. And have they said to simplify it? I'm not sure if they have. If they want us to do that, we can do, that'll be root, using surds, root 36, root 5, which is 6 root 5. And there you go. Hope that was helpful. If you have any questions, please ask below. And please like, comment, and subscribe. Thanks a lot.